Hey folks. Okay, well, let's get into talking a little bit about file handling. We haven't gone near anything like that for Lisp yet. So we'll take a look at file handling, we'll take a look at pipes, nothing too deep, but just so we've got the basics down. Lisp tends to follow a pretty conventional approach of, open the file or open the pipe, do whatever it is you're going to do with it, and then close it. So it's mostly getting the syntax down for the opening and closing and the different accesses. And again, we want to have our usual abilities to do things like, check if a file actually exists before we try and open it, that kind of thing. But it should be reasonably intuitive now that we've got the rest of Lisp down pretty well. So, a couple of useful functions in terms of setting things up and working with this. The probe file is a useful one for actually checking and making sure that the file exists before we try and do something with it. And then there's a couple of others for looking up properties of the file. So if you want to find out who the recorded author is or what the last modification date was, there's file author or file write date. If you want to get just the name, so if you don't want the full path to a file, you can extract it with the file name string. Or the flip side, if you want the path but not the file name, you can use directory name string. So again, handful of useful, fairly typical functions. There is one to delete a file, and that, of course, can come in handy. We will go through and practice writing some of these things and experimenting with them towards the end of the session here. Or actually, maybe we'll do file handling and then the examples on that, and then we'll do pipes as a second burst. So, one of the most useful ones we've got is with open file. So the idea is this will allow us to open a file as kind of a preliminary step, then do a bunch of stuff with it, and then close it. So we'll have a with open file, and it's the usual idea of kind of some local variables that get initialized. So we'll initialize a stream from the name of the file, and then a whole bunch of things to do with that opened file. Now, this is read by default, and you can specify you want to write to it instead. And the file automatically gets closed at the end of with open file. So with open file opens it, lets you do stuff with it, and then closes it for you. There are a variety of different options you can throw in. So again, by default, it's opened in read mode. You can throw in direction output to specify that you want to write to it instead. You can specify what to do with it if it exists or doesn't exist yet. So for instance, if you're writing to a file, you might decide that, okay, if it already exists, I want to overwrite it. You might decide that if it doesn't exist yet, I want to create it. So again, different options you can throw in. And then once you've got the thing open, of course, you can do all sorts of things with it. So you can use the traditional read. So if you wanted to just read one Lisp component, you could say read, and then whatever the name of our stream variable was. The nil is used to indicate what we'll do at the end of the file. Or I can read an entire line at a time. So read a line from the file. And again, this returns the line that was read. If I just use read, it returns the one element that was read. If you want to write to a file, you can use format again, but instead of the T or the nil, we specify the open stream that we want to write to. So this is saying open to the file that I've got open and whatever it is you want to write. A few other handy bits and pieces. Once you've got it open, you can check the length of it. You can figure out where you are right now in it if you're writing to the file and figure out how many bytes in you are, or if you're reading from it and you want to figure out how many bytes in you are. So again, a lot of fairly typical beasts. It's just a matter of knowing the name of the right Lisp function. So again, just a quick example here. If we say, okay, let's open a file, whatever the file name is, I'm going to write to it this time, and the stream that I open, just like file handles in C++ or something like that, the stream that I'm going to open we'll call my stream. And then I just say, okay, well, let's write something to my stream. And so just whatever it is you want. And you can throw your, tilde percents and stuff in it, and you can use your variables and whatnot in there. So just regular format statements, you're just specifying where it's supposed to go. Or the flip side is, if we want to open a file, read one line from it, store it in a variable, and close the beastie up again. Right, we'll set our variable up first, and then I'll say, okay, with open file, I'm just going to use S for my stream name here, and whatever the file name is, and of course the file name can be in a variable as long as it's a string. Let's set content to the result of a read line from that stream. And again, you can use the other read functions here, same sort of idea. And yeah, print it out at the end. So for the most part, it's pretty straightforward. If you want to go through and read the entire contents of a file, then you might do something like, throw in a do loop inside. So we'll say, okay, open the file, pick a name for your stream, and then we'll go through and say, alrighty, let's go through, and remember for a do loop, we had a bunch of variables that we initialized, so we give the name, a starting value, and the update value. So what I'm going to do is use a local variable for the kind of current line of text. So I'll call it next line, and the way I initialize it is by reading one line from the file, and the way I update it after each pass through the loop is reading another line from the file. So that's the current line of text that I'm working on. I'm going to quit when it's null. And so the idea is, again, this thing's returning nil when we hit the end of the file. So when next line is null, then you can print an output message, or you can return whatever value you like. Remember the last thing in this, we've got this stopping condition block. Whatever the last thing is in your stopping condition block is what it's going to return. So again, we'll play with some examples of this in just a second. And again, for whatever it is you want to do with the body. In this particular case, all we're doing is echoing the file content. So every single time we read a new line, we're just going through and printing it out. Instead, maybe I'd want to add it to a list that's got the content in it or something along those lines. Actually, I think that's the example that we'll do in just a sec. Actually, that might be a good point to, before we dive into pipes, let's have a quick play with some of this stuff. All right, so the idea is, let's start with a basic read. So what we're going to do this time is just read three things from a file. So what I'm going to do is I've got one function that's going to do the stuff with the file, but I'm going to have my script first off get the name of a file from the user and make sure that the file actually exists. So we'll come back to process file in just a second. So what we'll do in the main body of the script is, if you like, is we'll have a couple of local variables, one that's going to have the name of the file that the user provides, and one that's going to have the results of everything that we read from the file. So usual idea, prompt the user, enter file name, read it in. I'm going to use readline to read in whatever it is they type. So whatever it is they type in, I'm going to read that entire line of text. The reason for this is that way I'm guaranteed to read it in as a string. If you call just read for something like this, then it will try and interpret it as a list element. So if they type in something like food, we'll try and treat it as a symbol. And you might prompt them to say, okay, put your file name in double quotes, but that's a pain for the user. So I'm just going to read it in as a line of text. All right, so once we've read it in, actually this probably isn't necessary any further. We're reading it in as text, so it's going to be text, but you can throw in tests to make sure that they entered a string as a file name. Again, that's pretty much redundant because of readline. And then we'll make sure that the file actually exists, that it's something that I can access. So we'll use probe file on whatever file name they gave us, and if it doesn't work, then we'll tell them, I can't read that file. Otherwise, we'll call process file, the function up there, and just store whatever the results are and print it out. So pretty straightforward. And then in our process file, again, I'm just going to echo that I'm processing this just as a little debugging bit. What we'll do is we'll just read three list elements out of the file, and we better hope that it actually has three things in it. So I'm going to have local variables for A, B, and C. I'm going to say with my open file, create, this is my stream name, whatever the file name was they passed, and I'm just going to do three reads from the stream, and each time store the results in one of those three variables. Then I'm just going to make a list of the results to return. So this should just give me, as long as there's at least 3 things in the file, it should give me a list of 3 items, is the plan. So if we look at my input file here, it's got 3 things in it. So hopefully if I run my read 3 and I tell it I want it to read from input, it actually goes off and finds the hello that it read as a symbol, the list, and the number. Yay! We've also got a couple of other files here. You can see there's an empty file. So let's try it on empty just to see what it does. Yeah, we get an error because we tried to read past the end of the file without doing any kind of checks for end of file. So we'll look at checks for end of file in just a second. And let's throw one more. And for this one, let's take a look at what's in multi. So multi is same sort of idea. We've got a bunch of different things in it. I guess we've got some extra data in there. I think this should go through and read the hello, the 1, 2, 3, the list that's across multiple lines there, and it'll never get to the goodbye. Yeah, so seems to be working reasonably well. If we try it on a file that doesn't exist, hopefully it gives us an appropriate error message. Yeah, so we can go through and get this stuff working reasonably well. So let's instead try to maybe read some lines of text. Similar idea, right? The main chunk is going to do pretty much the same thing. We're going to enter a file name, check and make sure it exists, get the result of doing our processing. This time, what I'm going to do is go through the list of results and print it one element at a time. So I've just got a do list in here to go through that list of results and print each thing on its own line. And so what we'll do in processing the file this time is we'll build up a list of all of the lines in the file. So we'll go through and read this one line at a time and store each line as an element in the list. So pretty much the same idea, right? We've got our element for the current line. We'll do a read line to get it. So that's for initially, and a read line at the end of each pass through the loop. In the body of the loop, I'm just echoing that I read in this line, and then I'm consing it to the front of this list that I'm building up. So the first element, the first line gets read in, and then the second line gets consed in front of that, and the third line gets consed in front of that. So we're actually building up the list backwards. So at the end, once my next line is null, so I've hit the end of the file, I'll just reverse that list and return it. So hopefully we get things back in the right order. So if we try our read lines, and we give it our input file, it just had the one line. If we give it our empty file, it told us the file was empty. If we give it that multi, so this time it's reading by lines instead of list elements, and so we get each of those lines as a separate element in our list of results. So things seem to be working okay so far. Let's try the read all. And with this one, it was doing a similar idea. We're just using read. So we're going to read one element at a time instead of one line at a time. And I think other than that, things are pretty much identical. So of course, the only really interesting one for our read all is the that multi, where we've got list elements broken up across multiple lines. So let's just give that a try. And yeah, we get our first element, that hello, the second element, the integer, the third element is that list that was broken across multiple lines, the fourth element is that final string. So yeah, we wind up with our appropriate list of content, hopefully. Alrighty, we will actually, let me just take another quick look at our read all there. Oh yeah, we just print out the entire thing as one big lump instead of printing it out individually. Okay. Just wanted to make sure I understood what was, we didn't have a do list in there. All right, so we've got the I/O down fairly easily. Let's spend just a little bit of time looking at the handling of pipes. So again, the notion is that we want to be able to run some Linux command, let's say, and push information to it or read information from it. So I think a couple of examples we'll do here in a moment are we'll push a bunch of lines of text into a grep and see what it pulls out. And we'll try another one where we do an ls and read a bunch of content from that, see what ls found in the current directory. So the idea is we will use open, and then you specify the name of the command or the program that you're trying to run and a pipe to it. So you've got this text string we're opening a pipe to whatever the program is. And by default, it assumes you're going to read from it, but you can specify that you want to write to it. So if I say the direction is output, then I'm sending stuff from my Lisp code to the command. And if I leave off the direction, then it's assuming that I'm going to be reading from this pipe that I've got open. So, do a quick example with a read here. So we're opening some program, and we're reading one line from the output of that program and then closing our pipe up. Right, pretty straightforward. We can use the similar sort of idea to go through. We'll have it set up a do loop like we've been doing so far and just keep reading until we hit the end of the input. So in this case, we'll say let's set up a variable to keep track of our open pipe. So we'll do an open from ls really. We'll set up a do that again uses the same sort of technique we did before, where we'll keep track of the next line of input that we read from ls. So we'll just keep doing read lines on this until we run out. For this time, I'm just going to print out whatever comes out from the ls. So again, we'll stop when there's no next line. We'll close the pipe when we stop. And all we're going to do is each pass through print out the line that we just read. Right, and so we'll go through and do an example of that in just one sec. One of the things that'll come in handy with this is the idea of if something goes wrong, if for some reason we've goofed in the code that's working with the pipe and this thing crashes, then it's entirely possible that we want to make sure that we close the pipe anyway. So unwind-protect is essentially a little guard mechanism that says, okay, while I'm doing a whole bunch of stuff, if it fails, then do this thing at the end anyway, so I can provide a closing instruction that's going to get run no matter what. So in this case, I'm going to say, do all this stuff with my open pipe, but if something goes wrong, please make sure you close the pipe at the end anyway. So unwind-protect is often used as a guard around things like this, or like my let block with the do in it, or whatever it happens to be. So just as a word of note, if you start seeing unwind-protects wrapped around different things, it is just exactly that. It's a guard saying, if something goes wrong while I'm doing this, make sure you do the thing at the end to clean up. All right, so maybe let's just have a quick look at a couple of pipe examples. What have we got here? Let's take a look at the pipe to grep first. So in this case, we're going to send a bunch of things to grep and let grep play with it. So I'm going to create a data list here that's got a whole bunch of strings in it. So just a whole bunch of different random strings. And what I want to do is pipe all of these as lines of text through grep and let it pick out the ones that have got 330 in it. So I want to pipe this stuff into the grep 330 as my command. Again, I'm sending stuff to the command, so I want my direction to be output. And again, I'm going to create this just variable p to hold my open pipe. So open this command for me to send stuff to, and then I'm just going to send a whole bunch of stuff to it. So I've got this do list that's going to say for every string in that list, write it as a line of output to that open pipe. So all of this stuff is getting written into grep. Grep can do whatever it is it's going to do with it, and hopefully it's going to pick out the lines that have got 330 in it, and at the end we'll close the pipe. So the lines of text, there's the hello there, it shouldn't pick up that. The from CSCI 330, it should find that one, or it should pick out that one. The blah blah blah, it should ignore, and the 330 goodbye, it should pick out in theory. So if we give this a whirl, yeah, actually picked out the right things. So you can send stuff off to other programs or to Linux commands and see how we go. Let's take a look at the other one where we're getting input from the pipe. And so for this one, this is pretty much the ls example that we talked about a second ago, where this time I'm going to use data as a list to just store all of the things that come back from ls. So I'm opening up a pipe from ls, and again I'm just storing that in my pipe variable p. And what I'm going to do is read each line of input that comes out of ls. And usual idea, I'm going to stop when I hit the end of input. When I hit the end of input, I'm going to close the P. And what I'm going to do with this data is each new line that I read in, I'm going to glue on the front of my data list. So the data list is going to be backwards. So I'll just reverse that before I return it. And so again, what we're doing each pass through, each time we read one more thing, one more line from ls, I'm just going to cons that to the front of my data list. So at the end, all we'll do once all of this closes is we'll just print out whatever ls came up with. So in theory, this is the sort of set of stuff ls should find for us. And if we run our pipe from ls, then yeah, we get our lines of output from the ls. So now we can work with pipes as well in Lisp. All right, that's probably a good place to leave it. I'm not sure where we're going next in this. I guess next we'll get into the whole miscellaneous bits and pieces of Lisp.